Hello class, today we're going to be solving problem F10-8, which states determine the moment of inertia of the cross-sectional area of the T-beam with respect to the x-prime axis passing through the centroid of the cross-section. What a mouthful. So first thing I did was redraw my beam here with some dimensions. And since we're finding our y-bar first to get started with this problem, we're going to need the y distance from the x-axis as well as the area of each member here. So in order to find the distance to the centroid from each one, I just took its height here from the x-axis, which this one's 30, and I divided by 2, which gives me 15. I took this one, which the height is 150, divided in half, which is 75, but I've got to add this as well, which is another 30, so 75 plus 30 gives me 105. Those are going to give me my y's for this equation here. Now to get the area, I'm simply going to do base times height of each one. Those should be equal for each one, so that's pretty easy. And they'll put those all over the sum of the areas as well. So plugging all that in, you'll see my y values times the area plus my other y value times the area, all over 2 times the area since the areas are similar. This is going to give me y bar is equal to 60 millimeters. Next, we're going to see that we need to use the equation BH cubed over 12 gives us our I for this equation here. So once we start plugging in our values for our first beam, which is this bottom one here, of course, we're going to get 150 times the height, 30, cubed over 12, plus the area, which is 150 times 30. And then to get our distance squared, in order to get our distance squared here, we're simply going to take our x bar, which is 60, and go out to the centroid of each region. So if we take this distance as 60, half of that is 30, and then to get to the center of that right there, we're going to have to add another 15. That's going to give us that 45. Then if we take that 75 and add another 30 to get to the center of this one, that's 105. Minus 60, of course, is 105 here. Plug in all those values, and we get quite a number here. Simplifying that, it's going to be 2.7 times 10 to the 7th millimeters to the 4th power.